Hello everyone, in this video let's discuss about topological sorting. So to find the topological sorting and solve the problem we need two conditions. So if we look at the conditions for topological sorting, first one will be the given graph or the tree must be a directed. That is, if it is a graph, this is the graph. So this must be directed graph. Directed graph. What directed graph means? See, the direction is given like this. So this is a directed graph. Next, second one is acyclic. So what is acyclic? There must be no cycle formation in the graph. In this given graph there is no cycle. How? So if we consider starting from 1, so it went to 2 and it came to 4. So from 4 it is not going back to 1. So it is not going back to the point where it started. So we can call it as an acyclic graph. Now to solve the topological sorting problem, we will be doing the two step. So the step 1 will be, the step 1 is mark the in degree of each vertex. Mark in degree of each vertex of the given graph. What it tells is 1, 2, 3, 4, 5. We will call this as the vertexes. So mark the in degree. What is in degree? So if I consider a vertex, though the edges, this will be called as the edges. So if the directed edge is coming towards the given vertex, it is called as the in degree. If the directed edge is going out from the given vertex, it will be called as the out degree. So what they are told, mark the in degree of each vertex. So if we mark the in degree of vertex, it will be the first step. Now what is the second step? So second step. So the second step will be delete the vertex with 0 degree. Delete vertex with 0 as in degree. So if the in degree value of an vertex is equal to 0, delete that edge along with its vertex. Delete vertex with 0 as in degree along with its edges. So you must delete both the vertices and its edges. So what these edges do? These edges will specify the relation between the vertices. Now first, what they have told, mark the in degree of each vertex. Write the given question. 1, 2, 3, 4, 5. So this is the given question. Now write the in degree. How many numbers of edges are coming towards first one? So how many number of edges are coming towards this one? There is no edge, that is 0. Towards 2, only one edge is coming from 1, therefore 1. So 2 edges are coming towards edge number, vertices number 4. Therefore how many in degree? 2. For the third vertex, 2 edges are coming towards it. So 2 is the in degree. For 5, so only one edge is coming towards it. So its in degree is equal to 1. So what is the second step? Delete the vertex with 0 as an in degree along with its edge. What is the degree of the first vertex? It is 0. Therefore I must delete this vertex along with its 2 edges. Along with its 2 edges I must delete. It will be the new graph. So 2 is left, 3 is left, 4 is left and 5 is left. So we must also delete the edge coming from the vertex with 0 degree. So we also deleted these 2 edges. Now this is required. Now apply these 2 steps to this graph. So what is the in degree? 0, because no edge is coming towards that vertex. For 3, 2 edges are coming towards it. For 4, 1 edge is coming towards it. For 5, 1 edge is coming towards it. Therefore, 0 is with the second vertex. So I will delete the vertex number 2 along with its edges. So what will be the new graph? 3 is left, 4 is left, and 5 is left. So we must delete the vertex with its edges also. Now again mark the in degree. So in degree of 3 is 1, in degree of 4 is 0, in degree of 5 is 1. Therefore I will be deleting the vertex number 4 along with its 2 edges. So only 3 and 5 are left. Now mark the in degree of both. So in degree of 3 is 0, in degree of 5 is 0, because there is no direct connection between 3 and 5. Therefore you can delete either 3 or 5. So I will delete 3. So if I delete 3, only 5 is left. Its in degree is equal to 0. Therefore 5 will be deleted at the last. Therefore if we look at the answer, there will be two possible answers. That is, first we deleted the vertex number 1, then we deleted the vertex number 2, then we deleted the vertex number 4, then we deleted vertex 3, then we deleted vertex 5. At this step, if I deleted 5 first and then 3, what will be the answer? 1, 2, 4, 5, 3. So these both will be the correct answer. So this is the answer for the given graph we have sorted using the topological sorting method. Hope you understood the concept of topological sorting. If you like the video, please subscribe for more engineering related topics. Thank you.